How does the presence of vitamin D increase the amount of calcium that you absorb in your gut? So initially, this typically starts with a gland that sits up in your neck called the parathyroid gland, which detects the levels of calcium within your blood. And if calcium levels drop too low, that gland will increase the rate that it produces parathyroid hormone. So you can see here on this graph, right here, calcium levels are typically maintained at around 10 milligrams per 100 milliliters within the blood. And if calcium levels drop too low, so this indicates 10 is going down to 9, 8, 7 milligrams per 100 milliliters. If calcium drops too low, that gland will increase the rate that it produces the hormone called parathyroid hormone. And that hormone has an effect of generally increasing the amount of calcium because it's a counteracting effect. So decreasing calcium will cause this hormone to increase, and the general effect of the hormone is to bounce that calcium back up to what is normal to maintain calcium homeostasis within the blood. And so this relates to vitamin D, where vitamin D starts with cholesterol being converted into 7-dehydrocholesterol within the skin. And 7-dehydrocholesterol, which resides in the membrane of keratinocytes, can be converted in the presence of UVB radiation into vitamin D3. And you can also obtain vitamin D3 from the diet. And so this would be your form of supplemental vitamin D3. But once I have vitamin D3, it binds with a protein, and that protein allows it to be soluble in the watery environment of your blood. And so when this vitamin D3 is bound with a protein, it can then move through the blood, and there's an enzyme in the liver called 25-hydroxylase that converts that vitamin D3 into something called calcidiol, which is spelled calcidiol, which is an inactive circulating form of vitamin D. And then there's another enzyme located within the kidneys called 1-alpha hydroxylase that converts this inactive form of vitamin D into the active form of vitamin D called calcitriol. Calcitriol. And so this is the inactive form, this is the active form, this is the enzyme that converts inactive to active. And this hormone that we produced in the presence of low calcium, released by the parathyroid gland, has an effect of upregulating the amount of this enzyme called 1-alpha hydroxylase. So less calcium causes the production of this hormone, which increases the amount of this present, which converts more calcidiol into calcitriol. And calcitriol is the active form of vitamin D, meaning it's the form of vitamin D that binds most tightly with the vitamin D receptor. And what this allows for is within the small intestine, imagine this is our little small intestine, and these are some of the cells that line my small intestine. These are the cells that line my small intestine. The enterocytes. What happens is you'll have a little vitamin D receptor located within these cells. And if the active form of vitamin D, this calcitriol right here, comes over and binds with that vitamin D receptor, it can then induce the transcription of genes and the eventual translation of those genes to make proteins, which sit in the membrane of these cells, and they're transporter proteins that can move calcium from the space within the gut into these cells, and then from the space within those cells into interstitial space, and then those molecules can eventually diffuse into circulation. And so that fixes the initial problem where we started with low calcium levels. I released this hormone, which has an effect of this enzyme, increasing the conversion of calcidiol into calcitriol, the active form of vitamin D. And when I have the active form of vitamin D, it increases the absorption of calcium from the gut.